Hi, good afternoon. My name is Sean Magann. I'm the Chief Commercial Officer at Sims Lifecycle Solutions. For those of you who don't know about Sims, we are a publicly traded Australian-based ITAD company. And we consider ourselves an ITAD Plus company for the reason that most ITAD companies are involved in the reverse supply chain. We find, and I'll talk about it a bit more, we find ourselves heavily involved in the forward supply chain as well. That gives you an idea of some of the locations where we are, a few sites in the States, Brazil, India, a few sites here in Europe. The reason we have so many sites, and in addition to the sites you see there, we have a full network of subcontractors that report into my group. The reason we have so many different sites is moving materials transboundary can be problematic, and I'll talk a bit more about that here in a bit. So at the conference, we're hearing a lot about new servers, right? New stuff going in to support AI and some of the different applications. More? Yeah, thank you. All right. And so when stuff goes in, obviously it's got to come out at some point. More and more companies are trying to extend the use cycle of their equipment, but eventually the material will come out. And that's where we play. The question is, what happens to all this material? There's several opportunities when the material comes out to extract value, to create stock for spares, and with CXL, and also to reduce embodied carbon. So to touch upon these, let's start with the right. There's an intrinsic value to all this material. There's copper, there's palladium, there's other precious metals, and that's sort of the lowest type of reclaim we can do. I mean, there's certainly value to that, specifically with gold being at an all-time high a week and a half ago. And so that's good, right, to try to get the intrinsic metal value, but it's also probably the least valuable in terms of carbon reduction. And so what we try to focus in on is more to the left, to try to find value in the components and the units themselves on the secondary markets. There's a very, very robust market for CPUs, GPUs, and memory, which is great, but we're also finding, working with companies, Carnot and some of the other companies here at the event, that if we can use material for their intended purposes, on the second-hand market to maybe the second-tier data centers, it certainly brings more value to the supply chain, but it certainly is a better story too in terms of carbon reduction. Something that we're really, really excited about, and that is new to us and may not be new to this group, but is some of the saving. Well, there's two things. So in our business, the forward supply chain and the reverse supply chain used to be very, very separate. At the same time, the forward supply chain was trying to buy more stuff to support the equipment out in the field. We were scrapping things on the other side. And I get it, right? They're big organizations, and organizations sometimes tend not to talk. But working with some of our big hyperscaler customers and some of our other customers, OEMs specifically, we're able to utilize the reverse supply chain to offset the need for critical spares in the forward supply chain. So that's great. But CXL has been that sort of on steroids. What I mean by that is we have one hyperscaler customer in particular that in the last year and a half, we've put over 2 million DIMMs on the shelf to support their CXL needs, to support the next generation of GPUs. 2 million DIMMs. According to that client, the savings in terms of dollars has been in the billions of dollars, right? And so it's been a really, really big win, not just from a financial standpoint, the $2 billion offset, but from a carbon offset as well. I think a few people have touched upon the difference between the the 3 different types of scope emissions. I'll go through them briefly. Scope 1, obviously, are the direct emissions from the business that you do. So if you're a logistics company or a trucking company, Scope 1 are the emissions from the diesel that burn in your truck. Scope 2 are a bit more indirect. This would be from the electricity consumption. So if you're a data center, the emissions from the generation of electricity, you aren't generating the electricity, a utility is doing it for you, but there certainly is a carbon cost for that. And then finally, there's the embodied carbon that I think has been a big theme here at the conference, which is the carbon associated with the manufacturing of the equipment that goes inside a data center. Companies have done, especially data center companies, have done a really, really good job on the Scope 2, right? More and more of the energy used are carbon neutral energy sources. According to, I think someone mentioned it earlier, according to Meta, 99% now of their carbon emissions are from Scope 3. So going back to the DIMM project I mentioned, by avoiding having to buy 2 million new DIMM modules, a company, I won't mention the name, I think I just gave it away though, a company has avoided 2 million times their estimate of 12 kilograms of carbon per DIM. So you do the math, that's a lot of carbon avoided on top of the cost savings that I mentioned previously. So what are the challenges, right? So if this is what we're all trying to do in terms of sustainability, if it was so easy, why doesn't everyone do it? But there's 4 main challenges that I see. The first challenge is security. There's been a few sessions on storage media and the concerns about security. Most data center, most of the hyperscalers that we work with still tend to purge and physically destroy their storage media. Why? Because seeing is believing, right? When the hard drive's shredded, you get it's in little pieces, and the perception is that it's when it's in little pieces, the data's destroyed and the liability associated with that data. Is it true? Maybe, but the shredding has to be done, and on SSDs, the shredding size is very, very specific and very, very small, so that to actually get to where the data is physically destroyed is not as easy as it may seem. The disadvantage with shredding media is obviously you can't use it again, right? And these are highly engineered products, SSDs and HDDs. And so when you're shredding it, you're not able to give it that second life. The reason it's not done, it may seem obvious, but there again is a perception that if you wipe the device, erase the data on there, that there still could be residual data on the device. And as I mentioned, there's a ton of liability potentially associated with that. I think we can do better here. I think as an industry, and I think OCP is the perfect organization to work with. I think we can come together and find a way to where we can wipe the data in a way that people reasonably agree that it's effective and efficacious, and also allow us to reuse the hard drive. But this is a big, big issue in the data center space, and we in particular have a client where we're shredding millions of hard drives, SSDs and mechanical drives every year. And again, I get it, right? It's not for me to question what they do with their material, but I still think there's a better way to do it. But again, that's something I think collectively we can come up with a better consensus. Another big challenge, opportunity in our business is scale. If you're in a manufacturing business, the optimum conditions is you make a lot of the same types of widgets on a set schedule, right? That's where you get scale. You're manufacturing that one type of widget and you're doing 50 a week, 50 a month, whatever it may be. Our business tends to be the opposite. Our business tends to be eclectic, where we're getting lots of different things when a data center decommissioning happens, and it tends to be chunky. So we go from not a lot of material to a lot of material, and the material that we do receive tends to be a little bit of whatever comes out. It could be GPU racks, it could be CPU racks. It's a lot of different types of things. And as you would imagine, that can be challenging on our side because, again, like I said, it's chunky and it's eclectic. So what we've done is, well, first of all, I'd like to, again, acknowledge OCP's work on trying to make the material more modular. By making material more modular, when you put it together, it certainly makes it easier to take it apart. So that has been a huge help. And also the modularity has helped us automate the decommissioning of material. I don't know if anyone here has seen the videos from Molk, the robotics company, but working with them, we've really, really done good work on trying to automate the decommissioning of this material. And again, it makes sense because if material tends to be sporadic, you can turn robots off, you can't turn people off. So by automating the decommissioning, it's really, really helped, I think, bring scale to our type of business. I mentioned why do we have so many different sites. You may not be aware, but the same rules that dictate getting material into a country aren't necessarily the same rules that dictate getting something out of a country. Because once a piece of hardware is past its first useful life, in some countries, it can be, and well, even within some countries, it can be considered a waste. And so moving that transboundary or moving it within a country, say like in India between provinces, can be very, very problematic. It's not an insurmountable challenge. It can be fixed, but there's a lot of paperwork that's involved. There's a lot of notifications. And so moving material to concentrate it into big hubs where you can get that scale sometimes is not practical, because in our business you have to have multiple sites in different countries to minimize the effect of trying to move things transboundary. And I mentioned the material being different models, GPU racks versus CPU racks, but the material itself, when you're at the end trying to recycle it, again, it's a heterogeneous amount of material. There's plastics, there's different types of polymers in plastics, there's different type of metals. These are highly engineered products, and so when you try to recycle them, it can be difficult because there's not one process that'll recycle everything. In a perfect world, you throw it into a machine, and the gold would come out, and the plastics would come out, et cetera. It doesn't exist, right? So there's a certain amount of pre-processing that has to be done to recover the metals as much as you can, to separate the metals as much as you can, to make the recovery a lot easier. So again, I think a lot of the conclusions that we have are a lot of the themes that have been mentioned many times here at the conference. What do we need to do as a community? Well, let me back up. My conclusion is that there's a lot of opportunities for us to exceed, and the opportunities far exceed the challenges, right? I think we are just getting started in terms of circularity and minimizing the scope 3 carbon impact. So I think the road ahead, I think, is very, very sunny, if you will. I think all types of enterprises involved in electronics are looking to mitigate the challenges, right? Everyone across the board. And I think organizations, as I mentioned, like the OCP, are a perfect breeding ground for folks to work together to try to meet some of these challenges. And then what can we do? Again, keep collaborating, right? With just the last 2 days, we've had some amazing meetings with people from many different types of companies on how we're going to collectively meet some of these challenges. This is always, if anyone's ever heard me speak, this is always number one, better design, right? If we can design it for recycling or taking it apart in the beginning, it makes things easier on the back. I get it. This is a commercial industry, and folks are going to design things for what are going to sell, right? From a technical way or from just an aesthetic way, right? Just aesthetically pleasing. But by making things that are easier to take apart, it'll certainly reduce some of the challenges I mentioned and also contribute to lower scope 3 emissions. And again, carbon avoidance, right? It's a big deal, right? As again, I don't mean to beat a dead horse. I think we've been talking about this for 2 days. But the scrutiny that this industry will get, as we all know, because of the high amount of carbon, right? Both from scope 1, 2, and scope 3, it's going to get worse. And we need to collectively figure out how we as an industry can cut down on that. And I think hopefully some of the ideas that we presented earlier and some things that are happening will contribute to that. With that, I've got about 2 minutes here for any questions, if anyone has any.
Any questions?
Sir.
Thanks, Sean. I actually had 2 questions, but I'll only ask one for time. In the business that you make of harvesting the DIMs and returning them back into use,
Yeah.
is that are you putting them back to the same company that provided the end-of-life hardware?
We do both, but for the CXL example I mentioned, it is the same company getting rid of them and taking them again.
And
yeah.
my question there in that instance was, what is both the commercial relationship, like who owns the DIM? You're returning their DIM back to them, or did you buy it and sell it back to them? And the flip side, the other side of that coin answer is, from a carbon accounting perspective, who's scope 2, who's scope 3? It's like, oh, if you sold it, how does that all work? Maybe you can say a few words about that.
Yeah, really excellent question. So for the CXL example, the one I mentioned with the 2 million DIMs, title will stay with the client. So we're sort of caring for their material, right? So, and that's makes it easier for us, for there's tax reasons and a bunch of reasons where that works fine. In terms of the carbon part, I think that's the question, and I asked the question earlier during another session. Is there a ledger for carbon? And I think the answer that I've heard from different sessions, it doesn't exist yet. But that has to happen because there has to be an incentive for someone to want to reuse something, and there certainly has to be an incentive for someone to take a reused product. Now, when it's the same company, I think the math is easy. But when you're crossing companies, does company A that used it the first time, do they take the hit for 100% of the carbon? And the company B who gets it later, does he get a free ride? Exactly. So there's no incentive then. In that model, there's no incentive for someone. There's certainly incentive for the second guy to take it because he's got no carbon at stake. But for the first guy, he's going to say, well, just shred it then. There's no benefit to me, right? And so I think it's a really, really good point. Oversimplification, I hope I'm not stepping on any toes on that, but I think, I think there has to be a better ledger for carbon. But it seems like that's being worked on, so.
We are at time, so I apologize. I know you have a question. Maybe Sean can answer it off the record.
Yeah.
Thank you, Sean.
Yeah, thanks again, everyone. Appreciate it.